This is how you add a serial port to a router. If you click out in the white area and put your mouse over this router, this is a 1941 router. It only has 2 gigabit ports. On this router, number 2, same thing, 2 gigabit ports. And on this router, it has 3 gigabit ports. All right, so I'm going to add serial ports to these 2 routers. First of all, you need to turn off your router. You would do this in a live environment. You would turn off your device, you would slip in the card, screw it in, turn your device back on, and it would recognize the card. So we're going to be dropping this card into this slot. It says my device is still on. There's a little green light there, so that will tell you whether your device is off. So now I believe it's off. Clicked in there. I'm just going to put a cover over the other side so it doesn't get dusty. And then I'm going to turn this device back on. And you just need to verify that the device has a green light. All right, so now if I click in the white area and put my mouse over this device, it now has 2 serial ports. I'm going to do the same thing on this device, and I'm going to turn it off. I'm going to drag the card into the opposite slot and then put the cover on the other side and put the router on. So the difference that we're going to see here is when I put the serial ports over here, the ports are going to be serial 000, serial 001. If I put it over here, this is port 1. So the ports are going to be serial 010 and serial 011 as opposed to serial 000 and 001. So it's slot, port, and then port adapter. So we'll look at the ports and see how they're a little bit different. Again, I put this card in on the right side. So that's slot 0, port 0, and port adapter 0. If we look at this one, it's slot 0, port 1, and then slot adapter 0. So I'm going to connect these 2 cables together. I'm going to use my connections right here, and I'm going to choose the serial cable with the clock. The first device that actually receives the cable is going to be the DCE end of the device. So it's connecting from serial 0, and I'm going to connect it to serial 011. It really doesn't matter which serial port you connect it to, as long as you know that this just formed a network, and both ends of this connection need to get an address on that network. Now, in a real world environment, what we would normally see is we would see the provider for our network on our end, and on the other end, let's say one of these devices is in New York and the other one is in Hawaii. They're not going to have the same service provider. So what they would send their traffic to their service provider, and then the service provider would communicate with other service providers through their tier networks. And then our service provider would communicate with us. The service provider is the one that determines how quickly they're going to talk to our organization based on how much money we're paying them for dedicated bandwidth. So in a real environment, our serial cable is going to be the DTE end of the cable. So the DTE end is the data terminating end, and that is the end that just is receiving the traffic from the DCE end, data circuit equipment, or DCE end. So the DCE end is the one that provides the clocking. It's the one that determines how quickly am I going to talk to the device on the other side. So in the real world, your provider is the DCE end of the connection, and we as customers are the DTE end of the connection. But in our scenario, we don't have the providers. So in our scenario, we're going to get rid of the providers. and we're just going to use this cable between us. Now one end of the cable has to be the DCE side, and only one end of the cable has to be the DTE side. On Packet Tracer, you can see this little clock here. This is telling you you have the DCE side of the cable. So when you go and configure your IP address and subnet mask and bring your interface up, there's one additional command you're going to have to do because you're the DCE end of the cable. If you do not do that one additional command, this link will not come up and nothing will be able to flow through this link. All right, I'm going to go and give these devices the addresses 1.1.1.1/8, very wasteful address, and then the other side 1.1.1.2/8 networks have 24 network bits. That's 2 to the power of 24 will tell you how many host bits. We only need 2 for this connection, so it really should be a /30 network. /30 network only has 2 host bits, so 2 to the power of 2 is 4, minus the network, and the broadcast address will give you just the 2 addresses that you need. But we're just using these addresses for simplicity, but I just wanted to describe how wasteful this address is. So we're going to go and configure the serial 011 port on this device. We have a clean device, so it's asking us if we want to go into setup mode. We're saying no. Okay, and now we're going to go in and we're going to give this port serial 011 on this router, this address 1112. So interface serial 011, IP address 1.1.1.2 with a 255.0.0.0, and then we're going to do a no shut to bring that interface up. But remember, that interface cannot come up until the other side is also configured. So once both sides of this link are configured, then the interface will come up. But remember, we're going to do the same thing on the other side, but we also have to add that command, that clock rate command. Okay, I'm just going to grab this address because the other side is so similar. I'm going to copy it, and then I'm just going to go on to the other device's serial 000 and configure it. All right, so again, there's no config, so we are going to say no to get out of setup mode. So now we're configuring interface serial 000 on this router. So interface serial 000. I'm gonna paste in the address from the other side, but remember, 2 devices cannot have the same address. So we said this one was going to be 1.1.1.1, very similar to this address. So all I have to do is backspace the 1, 2, put a 1 in there, and I can hit enter right here. I don't have to go to the end of the line. Now I can do my no shut. But remember, we said that that interface was not going to come up until we did the clock rate. So this is everything we're trying to tell the interface to come up. And it actually did have a clock rate configured on it already. So if we look at the interface, let's do a show run. These devices actually come with clock rates pre-configured on their interfaces already. So that clock rate command was there, but that's how you would configure it if it was not. Clock space rate space a value, for example. So let me go back into that interface, and let's say that I was going to configure the clock rate. So I'm going back into interface serial 000. I would do clock space rate space. I can do a question mark. There are a lot of values that you can put after clock space rate, and again, this is the speed that your device is now going to be communicating to the other device. We can make it 128,000 if that's what we'd like. And how you could tell if your device is the TE end or the DCE end. And the reason why I'm saying that, let me just take you to some photos. And let's look at what that cable looks like. This is the DCE end of the cable. This is the DTE end of the cable. If you look at them, they look exactly the same. So you really can't tell by looking at the actual cable unless the labels tell you which side is the DCE end. And you would know that you would need to do the clock rate on that end. But the majority of the times, the cable does not tell you which end is the DCE and the DTE end. And again, they look alike, so you can't tell anything by looking at them. So what you need to do is you need to go into your device and actually look at that interface to see what it tells you, because it'll tell you whether it's the DTE end or the DCE end. So this is the command that we need to execute. Show controllers with an S, and then you put in your serial interface that you're trying to check on, serial 000. Hit enter. There's a whole lot of output. It's going to tell you more. We don't need to go any further than the first page. I'm just going to scroll back up. This is where I executed the command show controller serial 000. And if you see right here, 3 lines down, it tells you that is the DCE end of the cable. So you know that if it doesn't have a clock rate, you're going to need to go into that interface and do the clock rate. So now that interface is up. All right. So that's how you add a serial port to a router. The serial port will allow those two devices to communicate with each other. In this case, if we wanted to connect this router that only had gigabit ports, we could connect from our gigabit port on router 2 to the gigabit port on this router. So gigabit port to gigabit port, we can make this connection. This might be a metropolitan area connection, so Metro Ethernet. Traveling at gigabit speeds. So this is how you would connect your wide area network. Now Ethernet is considered a wide area network technology because of the speeds that we're able to get. So that's how you put in a serial interface.